So in this video, we are going to solve logarithmic equations in form of type 2. So the 3 steps would be to condense and isolate the logarithm first, write the equation in exponential form, and then solve and check for extraneous solutions. Remember, this value x minus 4, this value 4x plus 8 can never be a negative number. So you have to make sure that you do check your answers. So the type 2 equations, I condense and isolate the logarithm. This logarithm is isolated, although it has a group behind it, that's fine. So what we're going to do is we're going to write it in exponential form. So 2 to the 6th power, grab your base first, and that is going to equal to x minus 4. Then we're going to add 4 to solve for x, and that is going to end up being 64 plus 4. So x is going to equal to 68. Now, when I plug 68 in right here, 68 minus 4 is still a positive number. So I can keep 68 as an answer. In example 12, first thing I need to do to isolate the logarithm is to add 7 to both sides, so it cancels from here. So I have log base 3 of the group equal to 4. Now I'm going to rewrite 3 to the 4th equals to 4x plus 8. Remember, you grab your base, go to the other side, and then come back and get this number. So 3 to the 4th is 81 minus 8. I'm going to go ahead and do that in 2 steps. I'm going to raise 3 to the 4th and get 81, and I'm going to subtract 8 from both sides. So that would be 73 equals to 4x. Divide both sides by the number attached to x, which is 4. So 73 over 4 is my answer. Now, when I plug this in, 4 times 73 over 4 plus 8 should equal a positive number, and it does, so I can keep the 73 over 4. Now, in the next 3 examples, we are going to have to use a property of logarithm to condense. So what we're going to do is we're going to take these two and use the product property and write one logarithm of 2x times x minus 5 as one collected group, and that is equal to 2. Now, we've talked about common logs before. When you do not see a base number like we had with our 2 up here and our 3 in number 11 and 12, it's an understood base 10. So now I'm ready to grab my base, raise it to my power. So 10 squared equals to 2x squared minus 10x. I went ahead and distributed that value in there. So now I can reduce this problem. I can reduce every single number in this problem by 2, so that's what I'm going to do. Before I do that, I'm going to set it equal to 0 because it is a quadratic. So I'm going to subtract 100 from both sides. Now, that gives me x squared minus 5x minus 50. So now I need to factor this. So the factors of 50, or negative 50, that add up to negative 5 are negative 10 and positive 5. So I get 2 answers. Once you set your factors equal to 0, you solve them. So x equals to 10 and x equals to negative 5. Now I can keep 10 because 2 times 10 is a positive number, and even 10 minus 5 is a positive number. You have to check both the groups to make sure they stay positive. But when I plug in negative 5, I'm going to have to throw that one out because 2 times negative 5 is not a positive, and negative 5 minus 5 does not equal to a positive either. So although I did all that work and came up with 2 answers, I have to omit one and keep the other. In this problem, we are going to use our power property first. So that's going to be log x squared minus log of 4 equals to 2. And then I'm going to divide these. So that gives me, by condensing using the quotient property, a log minus a log, we end up with a fraction. So x squared over 4 equals to 2. My understood base is 10, so 10 to the second power. So grab your base. 10 squared is going to equal to this fraction, x squared over 4. That gives me 100 equals to x squared over 4. If I multiply both sides by 4, that gives me 400 equals to x squared. I can use the square root property and get x equals to plus minus 20. The square of 400 is 20. So I have two answers. So I am going to have to erase a little bit of this so we can check our answers. I actually have two answers. All right. One of them I am going to have to throw out because this number cannot be negative. So I have x equals to 20, which is okay. But when I plug in negative 20, it's not okay. Because this number has to stay positive. And if you replace it with a negative number, it drops out. So for examples 15 and 16, I do not have a power property that I have to do, but I do have a log base 6 plus a log base 6, which means I am going to pull those together with multiplication. So log base 6 of x plus 9 times x is going to equal to 2. So I'm going to take 6 squared, grab your base, grab your exponent, set it equal to those numbers. So that would be x squared plus 9x. I went ahead and took this and distributed it. So 6 squared is 36, so I'm going to have to subtract 36 and see if I can get this thing to factor, which you should. Most of these should factor. You should not have to do the quadratic formula. So factors of negative 36 that add up to 9 are positive 12 and negative 3. I get x equals negative 12 from this answer, and x equals to 3 from this answer. Now, when I plug negative 12 in, I get a negative answer, so I have to throw that one away, and I'm going to keep this example, or this answer. 3 plus 9 is 12, and that stays positive. Even here, if I plug in 3, it stays positive, so make sure you check all of the x values. Same thing we're going to do with number 15. I'm going to add these, or I've got a log plus a log. So I'm going to write one logarithm using my product property. So that would be x minus 3 times x equals to 1. Now we just talked about if there is no visible base, it's always a 10. So 10 to the first power equals to, I'm going to go ahead and distribute that, x squared minus 3x. I'm going to set the problem equal to 0 because it is a quadratic. And I'm going to see if I can find any factors of negative 10, that add up to negative 3. One of those is negative 5 and positive 2. The other one is a plus 2. So I get x equals to positive 5 from the first factor and x equals to negative 2 from the second factor. When I check my numbers, so 5 minus 3, that does equal to a positive. When I check this number, 5 automatically is positive. But when I plug in negative 2 minus 3 does not equal to a positive. So I throw that one out and I keep this answer. Now I want you to understand that you do not always throw out one of your two answers. Sometimes you throw them both out. Sometimes you keep them both. It just depends on the equation itself. So if you have any questions about the type 2 logarithmic equations, please let me know.